Hey guys!
Hey! So today we're going to teach you a little bit about why the sky is blue, rainbows,
The formation of red sunsets and red moons.
We hope you enjoy!
To start off, white light from the sun is actually composed of all the colors of the rainbow, the color spectrum, which is red, orange, yellow, green, blue, indigo, and violet. Each color of the spectrum has a different wavelength, frequency, and energy level. The color red has the longest wavelength, the lowest frequency, and the lowest energy level, whereas violet has the shortest wavelength, the highest frequency, and the highest energy level. These properties of light waves are key when it comes to understanding how light is absorbed throughout the sky.
So why is the sky blue? Well, in the atmosphere, the air is made up of millions or trillions of gas molecules and dust particles. Light waves usually travel in straight lines until they bump into these gas molecules or particles. When the light bumps into the dust particles, they usually are reflected off the surface of the particle and reflected into the sky. But something else happens when the light waves bump into gas molecules. When light waves bounce into gas molecules, something else happens. They are actually absorbed into the molecule. Then these molecules radiate the light off in different directions. This is when properties of light waves come into place. You see, light waves with longer wavelengths aren't absorbed as often. So this would include colors such as red, orange, and yellow. But light waves with shorter wavelengths, such as blues, violets, and indigos, are absorbed more frequently. This makes it possible for the gas molecules to radiate off the blue, violet, and indigo hues, thus giving the sky a blue tint. Usually because violet waves have the shortest wavelengths, they should be radiated into the sky more often. But because our eyes are sensitive to the blue color, we perceive the color differently. That's why the sky looks blue.
After it rains, water droplets are still left in the sky. And as sunlight passes through the air, light waves bump into these droplets. First, the waves are refracted, which means bent as we learned, and they enter the medium. Then they are reflected by the curved surface of the water, and then finally the waves are refracted back out of the droplet. This is important to know because it is the reason why rainbows appear as bent. Each color exists as a droplet at a different angle depending on its wavelength. The longer the wavelength, the less it is refracted by water. This means that the red light waves are bent the least because they have the lesser index of refraction. And because of this, violet wavelengths are the ones that have they're at the bottom and they have the most curve in them. Therefore, each color is separated from the rest based on the angle it leaves the water. So then, why is a rainbow a formation of different colors? This is due to the water droplets acting as prisms as sunlight passes through. Since sunlight consists of all the colors, the RGB, water droplets separate the different light waves, thus forming the multicolored
So what causes red sunsets? As the sun edges closer to the horizon, the path for light to travel increases. This means that light waves have to travel through more air particles. At the time of sunset, more particles are present in the air. The light waves have to pass through more particles, which results in a greater amount of red, orange, and yellow light being scattered around. The greater the amount of particles the atmosphere contains, the stronger the reddish tint of the sunset. The refraction angle between the sun's actual position and the visible one is 0.6 degrees. Blue and green light are also present. However, the most noticeable lights are red and green.
Red moons are actually similar to the physics behind red sunsets. Now you see, red light waves are the longest wavelengths, as we mentioned a few times before, and they have the smallest frequency and energy. Because of their properties, they have an easier time infiltrating through the Earth's atmosphere. When the moon is at a certain angle above the horizon, it is easier to see the prominent red wavelengths that have a higher potential than its siblings blue and green. Right, Mutsa?
Oh, hi.
Wait, I have to stop laughing. Tell me something not funny.